Okay, first up, your test for 11 opened yesterday. We are moving on to chapter 12 today. So for 11, you have until Monday, May 14th to get that done. Make sure you do that. The next test opens on the 16th. That's why we're starting the new chapter. We're almost to the end of the year. You have to have everything done by the 24th so I can get grades into Weber. So, the testing hours are both up underneath daily schedule for both chapter 11 and chapter 12. Nice thing about 12 is it sort of just builds a little bit on 11. So if you did well in 11, you'll do well in 12, kind of thing. So, and that's sort of how organic goes. Once you learn the basics, it's all about the basics all the way through. So today we're going to be doing learning about some unsaturated organic chemistry. We are going to I'm planning on doing 3 more labs with you, minimum, possibly the ice cream one if we can throw that one in too. But one of them is another model kit, and one of them is making polymers, where we make a whole bunch of different polymers and compare them, because chapter 12 is all about polymers and stuff like that. And then one of them is where we're actually going to learn how to blow and bend glass that's needed in organic chemistry to do different things. So that's what the plan is for the end of the year. So the only ones that you'll need to make sure that you have closed-toed shoes on are the polymers and the glass one. The glass one is a very big one. You want to make sure you have, because glass goes flying all over in that lab. So you might not want to wear shorts, or make sure you have a very long apron and it covers you front and back, because people behind you will have glass flying too. Okay, so that's what's up for today. What I would like to do first up is just sort of go over anything that you guys would like to about chapter 11. I know that you saw your test review. Hopefully you got the key on Friday when I wasn't here, where he showed you online, I'm hoping. Fifth period said they saw it. Were there any things that you still didn't understand, you want to go back over? If you haven't taken the test, what are you stressed about? What can I help you be ready for? I'll give you a few minutes to think and go with raise a hand. Who wants to ask a question first? And we'll go through a few things online, and then we're going to start chapter 12. Yes?
Can you do like the balancing thing?
The
rebalance it?
The what? The combustion? Oh, the combustion reaction. Okay. So for a combustion reaction like C6H14 plus O2 goes to CO2 plus water. Okay, that's just a basic combustion reaction. Now remember, if it says incomplete combustion, you're either going to get carbon monoxide or just carbon. So if we remember back from when we were balancing, we put down the center CHO. Remember leaving? Yeah, it's just balancing. The only trick here is you got to remember you got to use that little half thing. That's all about the carbon ones. So we have 6 on this side, we need 6 on this side. We have 14 on this side, we need 14 on this side. Now we have 2 on this side, we have 12 plus 7, which gives us 19, and that's where that little trick comes into play. So if I times this over here by 19 halves, I'm now balanced, because that will give me 19, but I can't leave a half there. So what do? I go through and multiply everything by 2. So this becomes 2, that becomes 19, and that was really large. And this becomes 12, and that becomes 14. Yes?
So how, like on the C6H14, how do you know how much isomers it has?
It just depends. You have to just draw them. And if it were me, I would just do the skeletal version. So, for instance, if I'm trying to find how many polymers this is going, I am just going to go 1, 2, 3, 4. That's the first one, right? And I could count these hydrogens by putting tick marks in, but I know every carbon has to have 4 bonds, right? And as long as I don't do double bonds or put it in a circle, I'm going to end up with H12. Okay, so here's 1, then I cut it down by 1, make it 5, and put something on the side. Put that methyl group somewhere else in the middle. Now if I put it here on this other one right here, it's the same as that one. So then I go down another one. Yes? Yes, it should be 814. Thank you. Okay? Yeah. All right, so then I go down to 4, and then I could have 2 things coming off like this. I could have 4 with 2 things coming off one of them. Can I do anything else? I can't go on the ends because what does that do? It makes the little chain longer. Okay?
Those 2 on the bottom left side, how are those not this? There's only one coming out of that, so.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So they're coming off different numbers. Okay? Can I take this one down to 3? Let's look at it. If I take it down to 3, then I have 3 more things I've got to attach, right? 1, 2, where am I going to put the third one? Because if I put it here, it now is a 4-long chain. Does that make sense? So then I can say, okay, I'm done. There's nothing else I can do. And I can count. Now, she's not going to give you a real long one. She's not going to say like C21. Okay? She's not going to give you a long one. But she'll give you one that you have to figure out. Okay? Good questions. Any others? Yes?
Can you go over like the weird ISO and like secondary kind of?
Okay? So this is how I remember them. ISO means the same on both sides. So whenever something's attached and I'm using ISO or sec, I know it's attached. So if it says isobutyl, so that wouldn't work. So let's try this again. If I said isopropyl, I would come down to the center and I would have the same amount on both sides of that center. That's iso. Okay? If I have, so isobutyl, we would come down 2 chains and it would be the same on both sides. Okay, so iso just means as I'm looking at it, it's the same on both sides of like a mirror. Okay, so that's iso. If I do sec, sec just means the second carbon is what's attached. So if I have sec-butyl, then as I come down on the chain of a butane, that's the second carbon that's attached. Now, she won't draw it nice and pretty. She'll draw it weird. So make it go out. Does that make sense? So she'll draw it like CH, CH3, CH2, CH3. Okay? So it'll look different. Or she might just take this part right here and go CH2, CH3 like that. So it looks not right. Does that make sense? So just spread it out and make it look nice. The T-butyl just means it's going to make a T. So, and it's a capital T. So even though it says a small t here, think capital T. So as it comes down, you're going to start here and you're going to make the top part of your T and then go down to the bottom. So iso is down at the bottom for the T thing. It's upside down, but T-butyl is up. Does that make sense?
Just whatever your chain makes?
Yeah, it's the shape that your chain makes. So the butyl or the propyl just tells me how many, and the sec or iso or T tells me the shape. Okay? Any other questions? These are good ones. Any others? Okay, I'm going to have a couple of you come up here. I'm going to just sort of introduce this next chapter a little bit by using a couple of you as guinea pigs. Who would like to be my guinea pigs? You're like, 1, yay! Yeah, come on up. All right. Thank you for being guinea pigs. So I'll have one of you right here. Okay, these guys are going to be pretend to be carbons, and we're going to bond them in different ways. So first bonding is just a single bond. Give them a handshake. Now, I'm going to hold this handshake steady. How can you move around this point? Okay, show them. How can you move? Blah, 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 blah. Okay, you can move however. Okay, that's what we've been working with is alkanes, single bond. Drop that. I want you to take 2 hands like this. Okay, now I'm going to hold them here. How can you move?
A little bit.
Okay, it's a little bit different. Okay, it's a little bit more restricted. Okay, now notice how far apart you guys can get. Okay, now I want you to do a triple bond, which means I'm going to have you same knee on the same side, up and touch. Same knee on the same side. There we go. Okay, what did you have to do?
Move closer.
You had to move closer. And is anybody noticing anything different about this bond?
It's really hard to move.
They're not stable. This is where we get explosives.
Sorry.
Sorry. Thank you. Okay, this is where we get explosives. So let's go back and talk about the different kinds of bonds. Oh, there was one other thing. This reminds me. I was going to show you conformations. This right here is what we call eclipsed conformation because they're exactly, that you can look down and they're right behind each other. So like when the sun is eclipsed by the moon, they're right behind each other. If I take and shift that a little bit, that one is known as, my brain just left. So it's eclipsed or staggered. Yeah, it's just simple, staggered. Okay, so it's either eclipsed or staggered. So, eclipsed, staggered. Single bonds twist like this all the time. Okay, so at any moment in time, they can be eclipsed or staggered. Okay, at any moment in time. Now, when we went from a single bond, and I forgot to finish building this, so I'll quickly build it real fast, to a double bond, maybe I'll build it fast. We actually took it from a 3D molecule to a 2D molecule because we restricted the movement that it had. Sorry, I'm not as fast as building these as I used to be. So we went from here to here. Now I can move these this way, but I can't move it up and down this way. Okay, it's residing in a plane. It's flat. It doesn't move out of that plane. So it becomes 2D. It's gone from 3D to 2D. When I then restrict it, what happened here when I made them go from 2 bonds to 3 bonds? I had to bring these 2 in and I had to really squish them, right? And I ended up getting this, which is very rigid and very stressed. Okay, so when I break one of these bonds, I get a lot of energy out. Okay, so we're going to take now and grab your notes. Hopefully, you picked them up as you came in, and hopefully they'll come up here. And we're going to talk about them. You have 4 sections in sapling to do. You've got your learning objectives. Now, in the last 2 chapters here, the learning objectives are going to be important for you to make sure you understand them before you go to the test. That's where she's pulling the test questions. So if you know how to do the learning objectives, you'll do well on the test. Vocabulary becomes a big part. Now, was some issues with the one I printed you. So sometimes yours will look like mine, sometimes yours won't. You just have to fix it because it was, anyway, we'll deal with it. So first of all, saturated hydrocarbon. That's what we learned about last chapter, which was what? Alkanes. Alkanes. So saturated hydrocarbons are alkanes. Okay. As we get to unsaturated hydrocarbons, what are we looking at? Alkenes and alkynes. Good. I'm looking for a smaller point marker, so keep writing. Alkynes. And I call them whinies because it's triple bonds. And alkenes. Whoops, forgot the L. Okay. Now, you do say alkynes, but you'll hear me call them alkynes. Just to remind you that they're whiny. They've got 3 bonds. They're really sort of, yeah, you know. Okay, so alkanes are what? Single bond carbon chains. And we're not going to do all of vocabulary today, but we're going to hit a lot of it. Alkenes, what do you think? Double bonds. carbon chain? What about Alkynes? Triple. I'm going to get tired of writing, so I'm just going to go like this. Okay. Then, yes?
So what makes alkanes a saturated hydrocarbon and the other one unsaturated hydrocarbon?
Okay, we're going to get to that today. All right, so what do you think halocarbon means? Actually,
With the halogen bonded with the carbon.
right, so we're going to have a halogen with a carbon chain. Now, what are the halogens?
Fluorine, bromine, iodine.
Right, so we're looking at fluorine, chlorine, bromine, and iodine. Astatine is not around enough to really make it, but if we could, I guess, could do that. Cyclic, you know this. What is it? Circle. Okay. Now, benzene becomes a little bit more involved. Benzene is a hexane ring, but it has 3 double bonds in it. So 1, 2, 3. It has 3 double bonds. You'll often see us write it like this because we get tired of writing the double bonds. So if you go get something from the pharmacy and it has this symbol in it, that means it has a benzene ring in it. Most things do. Okay, there's a lot of things that have benzene rings in them. Okay, geometric isomerism. We've done that before. Last chapter. What was it? Geometric isomerism.
Which is the difference between cis and trans.
That's our cis and trans. When did geometric isomerism work with alkanes? The only time we could use it for alkanes. When was that? When could we say it was a cis or as a trans with alkanes? It had to be a circle. Okay, it had to be a cyclic. Now, with what we're going into, so it had to be a cyclic. But here we're also going to be using them for, let's try that again, alkenes. Okay, if you'll notice the structure of the alkene again, whoops, zoom out again. Whoops, wrong way. Okay, I can get a trans position or a cis position because of the double bond, because it's rigid and doesn't move, just like when it was a cyclic and it didn't move. So it forces a cis and a trans position. Okay? All right, we'll go back in. Okay, so what is isomerism?
Same formula, different names.
Same formula, different names. Good. And trans, remember it goes like this, and cis, it will go like this, right? That's my shortcut for writing words, because, you know. Okay, when you think of polymer, what do you think? Polymer.
Wood and white something.
Okay, many of a chain. Okay, it's many of a chain. Monomer, what do you think? One repetition of the chain. Okay, that you guys can't see what I'm writing, that helps. Okay, so then we get to Markanoff's rule. This is sort of cool because you can say, I know Markanoff's rule. Markanoff's rule is sort of like what's happening in real life. Okay? The rich get richer, the poor get poorer. Okay? There is the exception to the rule where the rich get poorer and the poor get richer, but how much is that in percentage to the other? Very small. Okay? So, Markanoff's rule says the carbon with the most hydrogens gets more. Carbon with the least hydrogens gets the leftovers. And we'll talk about Markanoff's rule a little bit more later, so that makes a little more sense. Okay, we're going to go up to the top, or at 16, wherever 16 is for you. Addition reaction. Okay, math. Addition reaction. What is addition? Adding two things and getting one, right? Same thing here. 1 plus 1 equals 2. Okay, you're going to add two things and make them one. Acetylene is the common name for ethylene. So it's a carbon, double-bound carbon with hydrogen, 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 and hydrogen. So it's the one I've been showing you. It's C2H4. An aromatic has to have a benzene ring. So anything that has a benzene ring in it is called an aromatic.
So are they initially the same thing?
Benzene ring is just benzene by itself. An aromatic has a benzene in it. Okay? A phenol is where a benzene is attached to a chain. So like we were talking propyl and methyl and ethyl, well, if we have a benzene attached to a chain, then we call it a phenol. Okay, naphthalene is two benzenes attached to each other. And we're going to stop there for today as far as vocabulary. We're going to go on to the notes on the next pages. We'll come back to the rest of the vocabulary later. Okay. So looking at the next page here, nomenclatures of alkenes. I'm going to zoom out a little bit so I can get the whole page on there maybe. If it's too small, let me know and I will again bring it in. So we need to be able to classify saturated hydrocarbons, unsaturated hydrocarbons as alkenes, alkynes, or aromatics. Let's try that again. So alkenes, basically they just have to have a double bond somewhere. Alkynes, they have to have a triple bond. Whoops. Somewhere. And remember, it's going to be a straight line. Aromatics have to have a benzene ring somewhere. Okay? So we're going to just practice naming a whole bunch of compounds here, and you can see sort of what goes on. Now, the next little thing right here says, remember, bond, James Bond always wins, the lowest number. So basically we follow the rules. We locate the longest chain. Then we count how many to get to whatever we need to, and we name it alphabetically. So say that I had this chain right here. And we're going to add one more just because. Okay, so what do I go about doing to name it? Longest chain. Well, that's easy. Which way am I going to count? This way or this way? I'm going to go left to right. So 1, 2, 3, 4, 5, 6, 7. Okay, so 7 is what? Heptene. So this is going to be heptene. And where is that double bond?
On the fourth one.
You always put the number where it starts. So this is actually a 3-heptene. And done. Okay, so let's do another one. How about 1, 2, just to make it fun. Okay. Ooh, wait a minute. If I go 1, 2, there's something on 2 both ways, right? 1, 2, there's something on 2 both ways. So how do I know which way to count? Bond, James Bond, always wins. Okay, so we go this way. 1, 2, 3, 4, and of course I like to go up and do weird things. And then I know that I've got a methyl group coming off here, and I've also got to deal with this child Oh, my yellow died. How sad. Highlighter. Not smeared. Okay, so going forward. 5 is what? Pantene. Oh, wait a minute, not Pantene. It's going to be Pantwiney, right? Oh, I got red. Let's try this again. Woohoo, throwing pens, it's so much fun. Pantwiney. Where's the whiny at? 2 dash. What else is attached? The blue is a methyl. 1 carbon's a methyl, so we're going to put methyl in front of it. And whenever I have a letter to a number, it's a dash. And what am I going to put in front of the methyl? 4 dash. Good. Okay, I'm going to give you one I want you to try. Okay, here we go. Lowest number to the bond. We'll do some with some more bonds here in just a minute. We'll name some aromatics here in a little while, maybe next time. Just get the basics down today. Okay, don't look up until you're done. Okay, thumbs up, I got it. Thumbs down, I didn't. I had no clue what I'm doing. Well, there's more thumbs up than down. There's some sideways. Where are we lost on the sideways? Oh, got to make sure you're looking for the longest chain. So make sure you're going like that as I smear it. We're putting this away, so I will not use it again. We're getting out some colored pencils. Okay, so let's try another one. What happens if I end up with something like this? One, two. Which way? 1, 2. Am I going to start on this side or this side? Left side. Okay, so counting 1, 2, 3, 4, 5, 6, and you know I like to do weird things, 7. That means I've got this one to deal with, and I have, this one, and this one to deal with. Wait a minute, I've got a whiny and an E in the same molecule. Yes, that can happen. How am I going to name it? What is 7? Okay, so we'll do the hept. I'm going to put the methyl before because I know how to do that, right? So what's the methyl on? So 6-methyl. I'm not going to put the number in front because I've got 2 things going on and they both have to do with the ending. So what you do now is, alphabetically, this is an E ending, that's a Y ending, right? So alphabetically I go first, -2-EN, do not put the other E on it because it's not the end, -4-YNE. So I'm just showing them where every single bond is. So an ENE just means a double bond. A YNE means a triple bond. Yes? Bonds went over things attached. So if I went 1, 2, I have a methyl group attached on 6, right? but on 2 I have the beginning of a bond. So bond wins.
It doesn't matter what type of bond.
Doesn't matter what type of bond. Yes.
How would you pronounce that?
We don't pronounce it, we just write it. Organic chemistry is not meant to say out loud. It's meant to show you how to diagram. Yes.
So you wrote EN, you said that you didn't add the extra E.
Right.
Something ending of.
It's not the end. Right. It's not the end. Okay, so let's try another one. Let's see what we can do with this one. Okay, I'm going to have you do this one. I'll make it easier there. Okay, thumbs up, I got it. Thumbs down, I didn't. Oh, yes! My sideways one went up. Yes. Okay. All right, so we can do a whole bunch of other things too. Yes, did you have a question? Because there's nothing attached to it. It's just that chain. It goes before. Okay, I'm going to do one more real quick just so you can see what's going on with this. What if I had something like this? Don't give up. What did we do when we had more than one thing that was attached? Okay, so we're going to do the numbering again. So it doesn't matter which way I number this, right? Because either way is going to be the same. So I'm just going to go like this. 5 is pent, and I have 2 double bonds, right? So I can go, since there's nothing else attached, I can put it at the front, but we're going to put it inside. So pent, where are they at? 2, 3. How many are there? How do I say there's 2? Di-ene. Okay, same things we've been using. We're just using it now on the ending. Okay? All right, so let's look at this over here. We've got some structural isomers that we need to worry about for C5H10. So C5H10, in alkanes, we could go ahead and make a pentagon, and that would be C5H10, right? That's one structural isomer. Another way I can do it is I can put these 5 together in a row, but I'm going to have to show a double bond in there because it's too short on the hydrogens. So every time I put a double bond, it takes 2 hydrogens away. So every time I put an extra bond, it takes 2 hydrogens away. So that's one. Another one would be 1, 2, 3, 4. That. Do I have another one with 5? Not straight in a line. So now I can go to 4 in a row. And in the 4 in a row, I'm going to have to put a double bond here, and then maybe I could put a single off that. And I can keep going like that. When I add a double bond, I actually increase the number of isomers that I can make. So we can make a lot of isomers on this one because I can move that double bond around, not just move off a carbon. Does that make sense? Okay, so that's all I wanted to do there. This right here, when we start getting with chlorine, we're gonna talk with that a little bit in a minute down the road, right here, sort of, not really, but next page anyway. Cis and trans. That's what I was trying to get to. Yes.
How do you tell if there's a double bond in like just looking at the C5H10?
Okay, so if it's an alkane, This is a good question. If it's an alkane, the general equation is C2N H2N plus 2. If it's an alkene or a cyclic, I cannot spell cyclic, something like that, you're going to have C2N H2N.
Isn't it just 1 N for the C? Or is it
Still
still 2?
2.
So I thought it's doubled for the hydrogen plus the 2.
Oh, you're right.
And then it would be the same for
You're right. Okay, yes. CN H2N. There we go. I'm just wanting to double everything. Okay, and when I get to alkyne, then it's CN H2N minus 2. And I take away 2 for every double bond, every extra bond I have. So, for instance, when I had these 2 over here, I would have taken away 4 hydrogens from what I should have had. Okay? Good questions. Okay, so let's go down to the bottom here where we're talking about geometry. Geometry, right? My favorite subject in math. Not. Okay, so when we have an hybridized S or p orbital, it's basically like 2 balloons attached to each other. Okay, remember they're sphere-y things. They're not just the affinity sign, it's more of a sphere. When I take and I hybridize and make S and P go together, remember S orbit is a sphere, right? Okay, when I put them together, I actually get a little blip and a big blip. So I got a little balloon with a big balloon. Okay? When I hybridize 2 P's with an S, then what I get looks like 3 balloons hooked together. When I hybridize 3 p orbitals with an s orbital, then I get our tetrahedral shape where we have this with 1 in the back that's out there floating back. Okay, this is the tetrahedral shape. Okay, now, these are actually on your front too because we didn't define them, but I'm going to define them for you now. Double bonds. So what happens is a sigma bond, this is sigma, Greek symbol. It means I'm taking an s orbit and an s orbit and I'm overlapping these 2 s orbits, and that bond right there is a sigma. Okay? When I have a pi bond, I've actually taken, remember the p has an x, a y, and a z orbit. So we have one that's coming in and out of the plane there. When I do that and I take 2 of these and I have to actually, and I'm going to use color pencils here to sort of help. When I do a pi bond, I'm actually bonding this and this to make what we call a pi bond. Okay, so it reaches over top and bottom to make that pi bond. So we get this reaching thing going on. For each pi bond that I add, depends on, so this is a single bond, and we still always have to start with sigma. So I always start with a single bond. When I add 1 pi, I become a double bond. When I add, and I'm just going to put that by orange, when I add another bond, and I'm going to do this by pink, you see the difference, sort of, yeah? Okay, that means that I've now bonded these 2 to make another pi bond. So that becomes a triple bond. And that only leaves 1 p orbit not bonded. That's that one leg they were standing on while they were trying to hold that triple bond in place to steady them. Okay, so a single is just a sigma. A double is a sigma pi. A triple is a sigma 2 pi bond. Okay. Okay to go to the next page? All right, so we sort of already talked about what's at the top here. Remember, if we have a sigma and 2 pi's, we're going to end up with a triple bond, which is forced to be linear. So we're going to end up with our triple bond C, H, H, and it's going to look like our beautiful molecule here, like this, right? And that is ethylene, or also known as acetylene. We're going to skip down to the isomers, geometric isomers now. You draw them a little bit different than you do others. I'm going to zoom in right here so we can sort of go through it. A cis 3-hexene. I don't worry about the rest of it. I just look at, I've got one double bond, right? There's no di or tri in front of it. So I start with a double bond. I write C, double bond, C. Okay, then I look at the name of how many long that chain is. How long is that chain? 6. Good. It tells me that the double bond is on number 3, right? And it's in the cis position. So cis, I'm going to do both of them up. You could do both of them down. I do both of them up. Okay, so this is carbon 3, carbon 2, carbon 1. Now I have shown how many? 4. How many more do I need? 5, 6. What's coming off this are hydrogens. And at a double bond, when it is a cis or a trans, I have to show the hydrogens at that point. Okay, I don't have to show them on the rest of the molecule, but at that double bond, I have to show them. Okay, so if that's cis, how would I draw trans 3-hexene? I want you to try it. Don't look up until you're ready. Now, it doesn't matter if I put these on top, if these are flipped and these are flipped, no. Just as long as you're opposite. Okay, and you do have to show the hydrogen. So how many got that right? Okay, good. Okay, let's try the next one. We get a little bit more tricky. I'm going to do the cis with you, and then you get to do the trans. Again, start at the double bond. So, C, double bond, C. One's going to go up, one's going to go down. Since it's cis, I know I'm going to go up. Okay? Hexene, same thing that we did up above, right? 3-hexene. Right? Cis 3-hexene. So I can put that in real quick. There's my 3-hexene. I haven't put the hydrogens in because I noticed that there's something else before this. What is it? Bromine. So one bromine's at 3 and one's at 4. 1, 2, 3. Oh, there's a bromine here and there's a bromine here. The bromines are in cis position and the chain itself is in cis position. Now, you do the other one with trans. Okay, how do we do? Thumbs up, thumbs down, thumbs sideways. Oh, I love those thumbs up. That's awesome. Okay, we're going to just finish this page and then we're done for today. So, and you'll have time to work. Let's talk really quickly about properties. So, alkenes are like alkanes. As a chain length increases, what happens? Right. So I go from a gas to a liquid to a solid, and about the same amount of time. Okay, so chain length, as the chain length increases, I become more solid. As it's smaller, I'm going to be gas. Now, there is a table in your book on page 407 that goes through this with the density, melting point, and boiling point. Density, what do you think? If water is 1, is it going to be above or below? What are alkanes and alkenes and alkynes? They're nonpolar. Okay, why do you say that? Because oil floats on top of water, so it's less dense than water, so it'll be less than 1. Okay? And of course, the longer the molecule, the higher the density. Okay? All right, so when we talk about addition polymers, remember I said 1 + 1 is 2. That's basically what we're doing with addition reactions. We're going to write several different, and I don't know why I gave you the space right here. We're going to talk about Markov's rule, and I'm going to zoom out because yours got sort of blown away with me whiting out part of it. So this is what I was talking about before, where the rich get richer and the poor get poorer. So as I look at each of these carbons attached to the double bond, I look and say, okay, how many carbon or how many hydrogens are attached to this carbon right here? Directly attached to this carbon right here? 0. How many hydrogens are directly attached to this carbon right here? 2. Okay, rich get richer. I'm adding to it hydrogen chloride. So because of that, hydrogen is going to go on this side, and chlorine will be on this side. It will come in and break that up and attach. So over here on this side, I'll end up with C. Let me get these on. CH3, CH3, and then the Cl will be here, dash, because it'll break that double bond and make it to a single bond. Then I'll get CH3. That's my majority product using Markov's rule. Now, the minority product would be putting the chlorine on that end one. It does happen occasionally, just not a lot. Okay? All right, so that's where we're going to stop for today. We're going to come back to Markov's rule and do more of it next time. I want you to use the time to work on your sapling, to work on, remember we go to 25 after? Is it 25 after? It's sort of weird timing. You have time to work on your quizzes. You have time to ask questions. Whatever you need to get done for Chapter 11. Tests must be taken by Monday. Okay? Yes, there's one on my desk over there you're welcome to use, or there's one over there, I think.
So where's the key that everyone got on Friday?
It's also up online.
Okay.
Let me just stop this real quick so it doesn't hear it.